Hello, my name is Mica Cabrera. I am representing Cal State East Bay, and I will be presenting my research regarding antioxidant capacity in green tea, independence of water type, under Dr. Monica Sommerhalter. Green tea is a very popular beverage, mainly due to its health benefits, which include stimulating metabolism and preventing non-communicable diseases such as cardiovascular disease, diabetes, and cancer. These health benefits are due to green tea's high concentration in antioxidants, also known as catechins. The major catechins for this study are shown below. Epicatechin, also known as EC, epigallocatechin, also known as EGC, epicatechin gallade, also known as ECG, and epigallocatechin gallade, also known as EGCG. In a previous study by undergrad researcher Faiza Tahir, synthetic freshwater with different concentrations of sodium bicarbonate, calcium sulfate, magnesium sulfate, and potassium chloride were used to prepare green tea. And it was found that very hard water caused a brown color change and lower catechin yield than very soft water. So what exactly about hard water or very hard water causes this browning and decrease in catechin yield? Well, the purpose of my research is to show how water quality affects the catechin yield per cup of green tea. I essentially studied these 5 different types of water to see how components of very hard water affect catechin yield. I tested whether the mineral salt aspect or the carbonate aspect causes this catechin decrease, and I tested for oxidation as the cause in browning by preparing green tea with very hard water and argon bubbled very hard water, with a tea prepared in deionized water as the control. Standard procedure begins with weighing Bigelow Classic green tea bags and brewing the tea in 235 milliliters of water at about 70 degrees Celsius for 3 minutes. This was done in triplicate samples. To monitor the browning of the tea over time and its pH, I used UV-Vis spectroscopy, more specifically a nanodrop 2000, and to monitor the pH, a universal pH indicator was used. To identify and determine the concentration of catechins within the teas, I employed HPLC, also known as high-performance liquid chromatography, using an Agilent Infinity Series HPLC machine, an Infinity Poroshell pentafluorophenol column with these specific dimensions, and using solvent ratios of 2% formic acid in HPLC grade water and acetonitrile with 2% formic acid. So for the data retrieved from UV-Vis spectroscopy, the 5 different tea preparations fell into 2 different groups in respect to browning and final pH values. The control or teas prepared in deionized water and mineral salt water had respectively lower pH values, both around 5, and did not brown, whereas the teas that contained bicarbonate, the sodium bicarbonate, very hard water, and argon bubbled very hard water, all had significantly higher pHs, all around 7, and also turned brown, whereas the control and mineral salt teas were able to sit for days and not turn brown at all. The comparison of 2 HPLC chromatograms are shown in the side. This is a chromatogram of a catechin standard, and this is a chromatogram of an actual tea sample. Here it shows that the major green tea compounds, caffeine, EGC, EC, EGCG, and ECG, are detected and quantified. And using individual standards, I was able to determine retention times for each compound. And once each compound was identified through retention time, standards of different concentrations were used to create calibration curves by plotting peak areas versus concentration. The concentration of each compound was determined by applying the peak areas from the actual T sample to the calibration curves plotted from the standards. And here is provided an example of this, an example of the control Bigelow tea, or the tea prepared in deionized water, and the different components and the concentration of each component calculated using this process. Based on the graph that shows the different types of water and concentrations of catechins, show that caffeine, EGC, and EGCG all greatly depend on water type. The caffeine yield was higher due to alkaline conditions, therefore showing that caffeine favors the alkaline conditions of sodium bicarbonate, very hard water, and very hard argon water. Both EGC and EGCG share similar trends in having the lowest yield in water with bicarbonate conditions. Judging from the error bars in the graphs as well, the compounds with the most variance were caffeine, EGC, and EGCG. EGCG is the most powerful antioxidant as well as the least stable molecule out of all the green tea catechins, with more attached alcohol groups and a carboxyl group, which increases its likelihood to react. EGC and EGCG both have more attached alcohols on one of the ring systems than ECG and EC. Instability of EGC and EGCG may explain the large standard deviations found for their content in more alkaline conditions. So the measurement process for this experiment was very time sensitive, which is an important limitation to this project. The first HPLC run of every new sample was always the one with the highest amount of catechin, and repeated runs of the same sample showed that EGC and EGCG were the most unstable of all the catechins. And instability of EGC and EGCG therefore indeed explain the large standard deviations. The limitations for the argon experiment was that the argon used to displace the oxygen may have also displaced carbon dioxide as well, which shifts the equilibrium, causing the conditions to be more alkaline. So although the oxygen was displaced to prevent oxidation from occurring, the tea remained with a pH that was more alkaline. So using HPLC, I was able to detect and quantify the major green tea catechins and caffeine. And all the tea samples with bicarbonate had slightly alkaline pH values, turned brown more easily, and had lower overall catechin yield. The highest total catechin yield was the controlled tea used with deionized water, having about 37 milligrams per cup. And the lowest total catechin yield was the sodium bicarbonate tea, having about 28 milligrams per cup. And that concludes my presentation. Thank you very much for your time.